Next topic we got force due to n number of point charges. See, for example, in the previous session we discussed about what is the force between the two charges. So how the force will be the between only between the 2 point charges literally. So now instead of two charges, we'll take some n number of charges. For example, we have Q1 is one charge, Q2 is other charge, and Q3 is other charge, and so on till Qn. So these are the different charges, and there is one more. This is called the test charge, for example. This is not different. This charge is not different with this compared to this charge, but I'm saying this has a test charge. Now, if you consider, of course, there are many charges Q1, Q2, Q3, and up to Qn. And what is the force here in this particular heading? We discussed like what is the force due to n number of point charges on a single test charge. So for that, so what is the force applied on Q by Q1? So here this is Q1 and here this is Q. I'm not giving any suffix here. If that is the case, if you consider the force in this direction, because it is very clear, the force applied, the force exerted on Q because of Q1. I'm just representing this as F1. This is not just F1, this is F1 bar because it is a vector. Similarly, we can say the force between Q2 and Q, the force between Q2 and Q, I can represent as F2 bar because it is a vector. The force is a parameter which contains both magnitude and the direction. In the similar way, we have the force between Q3 and Q. So this can be said as F3 bar. In the similar way, we have Qn and we can represent as F suffix n whole bar. So these are the forces, these are the different forces acting on Q by these different charges. And what is the total? See, now the Q, the test charge, is experiencing some force from all these charges Q1, Q2, Q3 and Qn. And what is the total charge? We already discussed in the previous class and in the previous session. Like for example, every charge is placed in a point in a rectangular coordinate system or in a spherical or in a cylindrical coordinate system. Now here also we are considering the rectangular coordinate system in which Q1 is in some point P, whereas Q2 is in some point Q, whereas Q3 in some point R, and so on up to N. It can be any point. It can be any point. And this is this Q test charge in some other point, like for example X or any point. So now, what is the force? What is the force exerted from the last session formula? The force F1 bar, I can represent it as F1 bar is equal to Q1 into Q, because Q1 is nothing but the value of this charge Q1, and Q is the value of the test charge, by 4 pi. If you consider the medium is air, this can be represented 4 pi epsilon, and we already know down the vector, the actual vector of the force between P and X, the points between P and X. So it can be like Px bar divided by mod of Px bar whole cube newtons. This is the F1 bar. So this is the force because of Q1 on Q. So here, this particular test charge is experiencing force not only from the Q1, it is experiencing the force from Q2, from Q3 and so on. So the total force, we can write as total force. So this is also a vector because wherever the force is there, it is a vector quantity. So always should be represented as a cap or a bar, however you represent. So this is equal to total. So F1, so it is a superposition of every force. So F1 vector plus F2 vector plus F3 vector and so on F1, Fn vector, because Fn stands for the force exerted on Q because of Qn charge is called F1 vector. So the total force here is, this is the formula. You can consider the formula. This Yeah, so this is the total force exerted on Q because of various charges. So this is the complete formula. Now, based on this, we'll discuss one problem so that we can understand much elaborately. Yeah. Based on the Coulomb's law, we have one problem to deal with. So here we have the problem like, so we have 8 point charges of QC. So of QC each are located at the corners of a cube. I'm going to explain the problem first, okay? There are 8 point charges. So we have 8 point charges are in a form of a cube. They're located in a sides of cube. Like for example, this is the cube for example. There are 8 corners in a cube in which QC charge are placed in every corner. So, and the length of each side of the cube is a centimeter. It can be a centimeter or meters or whatever, but here we are taking a meters according to the problem. Now, if you see carefully, the corners of the cube of side length a. So every corner of the cube is having the length of a is a meter. If you take a meter, so that's why we are writing every corner having length, every corner having length of a meters. Now they gave one condition like with one charge at origin. So here we have one charge. Let's take for example A, or it can be G. Anything is a point. So at G we have is origin. So and which the 3 nearest charges at A comma 0 0 meters, 0 comma A comma 0 meters, and 0 comma 0 comma A meters. So they're not very clear. The problem they discuss very clear, right? So there is a charge QC at the origin, and for this charge, the nearest points are, one is A at 0 comma 0 comma A. I'll tell how these values came into the picture, and B at A comma 0 comma 0, and at C. So this is C from here to here, from the origin, which is the nearest one, 0 comma A comma 0. So what we're asking here, find an expression for the total vectors. Find the expression for the total vectors on charge at P. So here, what they're asking is literally, what is the force at a point P? What is the total force exerted on the point P, which is located at A comma A comma A? So assume this particular cube is in free space, and it is also filled with the free space. So this is in brief about the problem here. Let's take for example, let's understand much clearly about the every point and what are their values. See, for example, here they took, this is the origin, this is the reference point G. So G is a reference point. It is situated as 0 comma 0 comma 0. So there we have a charge QC, very clear. So here, we are taking this particular thing in a rectangular coordinate system which contains all the 3 coordinates like x-axis, y-axis, and z-axis. So that reference point is not at all subjected to all these 3 axes. So that's why we wrote as G in the point is the origin like 0 comma 0 comma 0. So in the origin, so we have a charge QC, and here, so A, what is A exactly? A we are representing as 0 comma 0 comma A. So A is a point. In the point A, we have one charge called QC. So the location of the particular point is 0 comma 0 comma A. Why it is called 0 comma 0 comma A? So here every point is representing x comma y comma z. So this particular point A is not in the x-axis, not in the y-axis, but it is only in the z-axis. That is the meaning of these particular values. We should be very careful in dealing with the values. And in the similar way, what is a B? So B is nothing but we have the value A comma 0 comma 0. That means B is a point of a QC located in the x-axis, only in the x-axis. It is not subjected to either y-axis or z-axis, but it is only in the x-plane. In the similar way, we have a C. So here we can say as a C. C is nothing but 0 comma A comma 0. Like for example, 0 comma A comma 0. Here also we have a charge QC. In the similar way, all this QC is located at 8 corners of a cube. So we have C here and we have E here. So E is located in both the planes. It is located in X and Z plane. So A comma 0 comma A. So there also we have a charge QC, and F if you take. So here also it is also located in YZ plane. So we finished. So A is got over B, C. So this is D. D is only in XY plane. It is not in the Z plane. So A comma 0. So there also we have a charge QC according to the problem. So this is how you should understand the points. This is how you should understand the coordinates of every point where the charges are present. If you see carefully, we have 8 corners and we got 1, 2, 3, 4, 5, 6, 7, and there is one more corner which is nothing but P here. So P, if you see carefully, P is this particular point which is having the impact of all the 3 coordinates. Like that's why we can write as A comma A comma A. That means it is in the free space which is having a relation with all the 3 coordinates. So that's why A comma A comma A. This is the coordinate point in which one more charge is present, which is nothing but QC. Now, so what is the problem? According to the problem, what we have to find here is very simple. So what is the charge on this particular point? So here also we have a QC. Every corner we have a QC. A is also having QC. F is also having QC. C is also we have QC. D also we have QC. QC is nothing but it's a simple notation. It's not something very different one. It's a normal notation of representing a charge. It can be anything. So here also B also we have at a point B. It is very clear that at point B we have a QC. At point E also we have a charge called QC. So now there are different charges at different points. Now, according to the problem, what we want to find literally is what is the force exerted on a charge QC which is located at P by these charges which are located at 7 different locations of a cube. So this is how you want to find the you want to find the total force exerted. For example, if you take A, so from the point, so we have QC at a point A. Because of this, I told very clearly from the Coulomb's law, any 2 charges can be attracted or can be repelled, and the force between these 2 charges can be represented by the Coulomb's law. The similar way, the force exerted on the point A's charge on the point P's charge is said to be the Coulomb's law notation. So we can say this is the force exerted like this from A to P, and there is one more force from G to P, and there is one more force from E to P, F to P as well, C to P, D to P, and B to P. So all these forces are showing impact on only one point according to the problem is at P. So whatever the charge QC present at the point P is experiencing the force from all these 7 charges. So for that we are having the representation. For that we're going to discuss the problem in deep right now. So the force equation, as we discussed earlier. So the force equation, the force vector at the point P, that means the force experienced by the charge at the point B, P is equal to force because of the charge at point A plus force because of charge at point B, force because of charge at point C, plus force because of charge at point G, nothing but origin here, plus force because of charge D, plus force because of charge at point E, and then force because of charge at point F. So this is the total force on charge P is equal to FA bar plus FB bar plus FC bar plus FG bar plus FD bar plus FE bar plus FF bar. So this is the total force according to the discussions we made from the. Now we will discuss much in much detail. We have a much elaboration now here. So how to find, how to crack these equations, how to get the final output? That is our logic here. So here the main logic here is if you go for examinations or any other thing, analysis. Analysis is the main concern here. So how the problems will be given and how you should understand the problem. That is a major thing. Once you understood the problem, once you got the real logic, you can do the problem with the usual flow. So to remove the confusion, we're going to explain much elaborately. But anyhow, so we'll take one or two forces, and at last we'll get the complete equation. So how this particular force equation will be. So now, if we take the force Fa bar, usually this is calculated from the Coulomb's law, which we discussed earlier. So according to the Coulomb's law, it states that the force between the two charges here. So here the charges are A is at the point of 0, 0, A. So if you consider how to find Fa bar, so the same logic, the same phenomena is applicable to calculate the force between B and to the P, or between C to the P, or between D to the P, and so on. So whatever, first of all we'll find Fa bar, so that the same logic applies to everywhere. But at last I will let the complete the generalized output for this particular problem. So Fa bar is equal to the force between the charges QC between and P. So we have point A here and we have point P here. So this is point A, these two are in the Cartesian system. So the entire problem we are designing, we are making considering the Cartesian system, Cartesian coordinate system. It is also called as a rectangular coordinate system. Here A is having the charge QC, whereas P is also having the charge QC. We are not giving any notation like plus or minus charge, we are just according to the problem we are just choosing. And it is very clear for us the distance of every length or every corner or every edge is same, which is nothing but A. So first of all, so this is located, this point is A, located at 0, 0, A. That is, the point A is located in the z-axis only. It is not related to x or y-axis. Whereas if you go for P, it is located, it is having the position representing or in relation with all the three axes. So that's why P we can say as A, A. P is we can say as A, A. So these particular coordinate systems and their points are they are very easy to understand. They're very easy to notify also. There is no much logic over there. So based on our general circumstances, I'm noting A and P points. Now we know the formula Fa bar is equal to the multiplication of the two charges. Here the charges are equal. So QC is a charge at A and QC charge at P according to the problem. So we can say as QC square, because QC into QC is nothing but QC square, divided by 1 by 4 pi epsilon naught. Why I am saying epsilon naught? In the problem they give very clearly, assume the free space. If you assume the free space, 4 pi epsilon naught will be the value here. This is nothing but a proportionality constant 1 by, so K is equal to 1 by 4 pi epsilon naught. Now here comes what is the value. So here we already know the value, like for example, the force is moving from A to P. So the vector is also between A to P. So the actual vector we can represent as AP bar divided by, we already got this notation. We can write these as AP bar whole cube newtons. This is the formula for FA bar. In the similar way, you can find FB bar, because B is a point of here A, 0, 0. In the similar way, you can find FC bar and so on. Now, so first of all, we'll go for much elaboration here. So what is AP bar? What is AP bar here? Very simple. In the last example we discussed, AP bar is nothing but a vector between the 2 points we are calculating. So how, if you go for recall, this is x2 minus x1 ax vector plus y2 minus y1 ay vector plus z2 minus z1 az vector. So for your better understanding, I am going to erase this parameters here. I'll rewrite at last. So now you consider only between A and P. So I'll A and P here. P. So this is at the point, we already know that it is at the point of 0 comma 0 comma A. This is at the point of A comma A comma A. So if you consider, this is the generalized formula for AP vector. So this I can represent as x1 comma y1 comma z1, and this I can represent as x2 comma y2 comma z. Now AP bar I'll write here. So AP bar will become like, for example, x2 minus x1. So x2 minus so A minus 0, nothing but A into AX vector plus y2 minus y1. So which is nothing but A into AY vector. So don't get confused here. So Z2 minus Z1. What is Z2 here? A minus A0 into AZ vector. However, I'm representing this notation, the same outcome is this. So this will become 0 AZ vector, nothing but 0. So I will discard this entity. So this is AP bar. And in a similar way, what about AP bar whole mod? So this is the scalar, whereas this is the vector. It contains the unit vectors in every direction. Whereas scalar doesn't have any vectors to be in the equation. So you know the formula which we already discussed before. If you consider the distance between the 2 points, like x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this part we can erase. I will rewrite the force equation again. So now AP mod, nothing but a magnitude of the vector, so you represent it as square root of x2. What is x2 here? A minus 0 whole square, nothing but a square, plus y2 minus y1, a minus 0 whole square, nothing here also a square. So this will be a minus a 0 square, just I'm keeping as 0 square only. So this will become as root 2 into a, always in the form of a meters. So here we are assuming the distance between the 2 points is in the form of a meters. So now the force equation can become, so FA bar will become QC square, 4 pi epsilon naught into, what is the AP bar? So this is the AP bar vector, A into AX bar plus A into AY bar divided by magnitude root 2 into A whole cube. Yeah. So now we got the value of FA bar, and in the similar way we should find the value for FB also. So FB bar, so this is the vector between this is the vector to find out the force between the charge which is at the point B and at the point P. So there also we can find in the similar way how we are calculating the FA bar. So at last, so the total force P bar which we discussed earlier, like which is nothing but FA bar plus so in this particular problem, how we find out the FA bar, the similar way we should find out the FP bar, FC bar, FD bar, here is FG bar. So FG bar plus FE bar plus F bar. So this is the charges at every point. So if we add the complete the forces, like how we got the expression for FA bar, if we add the complete forces from point P to every point, so the total FP bar in this particular problem will get like 1.89 AX bar plus AY bar plus AZ bar newtons. So this is the complete output. This is the complete equation we are going to get once you solve at every point, at every stage. So this is, yeah. So this is how we should solve the problems regarding to the forces between n number of charges on a particular point charge. So these type of problems are very they're not so tedious. They're very interesting. So I hope everyone can practice well these sort of problems. Thank you very much.